So I recently bought a desktop CNC mill just to use for little projects at home, and I also bought some of these little copper clad boards, and I'm hoping to learn to use it to create some little circuits and PCBs that I can use in those projects. I've got a little bit of experience with CNC before, about 10 minutes worth in software. So here we go. I made this once. Old CNC mill out of wood. It ran for about 10 minutes before something broke on it and I never used it again. So I've used some softwares before, but mostly we're going to this new. So hopefully we can come out of this with some nice circuit boards.
Breadboards like these are sound when you're just starting out a project, so you just need to plug some things in and make sure they work. But as a product develops, they're a bit cumbersome, and it'd be nicer to switch over to a metal PCB that I can just solder the components to and have them stay. In my CAD software, just to quickly check the calibration of the CNC, I created this shape. It just has some larger squares of 1 centimeter each, and then some smaller squares slightly smaller. And it's going to have 5 tool paths, so it's going to be drilled into 5 different times. Once on the outside, then once for each of those squares, and this left square we're going to fully carve out the copper, whereas everywhere else we're just going to remove a single bit of copper that's stripped. I attached the copper clad board to the base of the router using some sacrificial wood and the clamps that were provided. I also wanted to properly probe the Z depth, so I attached some probes I got to the end mill piece and also the copper clad piece. And that's these yellow bits now. And this pretty much forms a continuity check, and it checks if the end mill is in contact with the board, and just lets you get a perfect height to make sure you don't do anything slightly wrong. Of course, saying that, I attached them and immediately pressed the wrong button. After sorting that, reattach the probes and send away the job.
Okay, so here's how that first run went. So we can see here that there's actually still some copper left in the grooves around here, and that means on these bits the drill bit wasn't cutting quite deep enough, and that suggests the board wasn't perfectly flat, as if it had been flat across the whole CNC then everything would have been the same depth. And we're able to check this by using the heat map on our CNC interface software. So I'm using Candle in this situation, but most CNCs will be able to do this. And that can just map the whole surface using that Z probe that I showed you before. And once we'd height mapped a new area and reprinted, you can see now that the lines are way more consistent across the board. So I've had a few successful tests. Alright, it's time to give it a go, see if I can cut a board out. I did notice that my smallest end mill piece is quite a lot bigger than most PCB holes. So it might not work too well, but we'll give it a go.
I decided to go with quite a simple circuit design, so it's just a push button turning an LED on and off. When I cut the board out, I noticed pretty quickly that the traces seemed too narrow. When I zoomed in with the camera, I could see that the copper was actually missing from some of them. So I cut another one out with slightly wider traces, and I also cut the edges out as well. By zooming in with the camera and also using a backlight, the traces were still too narrow, so I had to try a few more times.
So you can see this one's a lot cleaner, and just slightly too thin still on some of those traces. That's pretty much perfect. Okay, so after a few attempts I've got a pretty solid looking board cut out there. So all I've got to do now is solder the components to it. Unfortunately, I didn't have an end mill small enough to drill the holes through, and the one that I had was just way too big. So I'm going to have to try and solder the components to the same side as the copper, which might be a bit awkward, but we'll give it a go just to see if it works.
On the larger solder pads that I'd made, such as those for the power terminals and the button, I was able to get the solder to flow onto them fairly well. But as soon as I tried to put the solder onto the smaller pads, such as those for the resistor and the LED, I realised it just wasn't possible, they were way too small. Since the board wasn't going to work anyways, I decided to try and put the button in place, just to see how that would be. And it wasn't too bad, I was able to get it to stay in place, although I was able to pull it off fairly easily later on, and rip the pads at the same time. So I just need to be careful with things mounted this way. It took quite a few more iterations to get the trace width right, and to avoid getting too many problems with the traces separating from the board, but after that I did manage to get it right.
So in conclusion, we were pretty successful at making this little test circuit board. Even though I didn't have quite small enough end mill pieces and cutting bits, I was able to make something that works. So that leaves us pretty confident for any future project that I'll be able to create the boards I need to make them successful. So I look forward to moving on from here and seeing what I'm able to make.